Hello everyone and welcome to the new episode of MSL to Live. Today we are going to talk about two different topics and try to combine them, IoT and DevOps. And today we have a very special guest, Pete Gallagher with us. Pete, welcome.
Hiya.
Before we start for the newcomers, because we had a session last week, can you tell me about yourself? You own a company and you're running a community.
Yeah, so I'm Pete Gallagher. Hi, I'm a Azure MVP, and as Mert's pointed out, I'm a freelance software developer for my own company. I've been doing that for quite a while, and I run a few meetups in Nottingham, .NET Knots being one of the biggest ones. And I'm here today to talk about IoT and DevOps, which you don't hear much talked about combined.
Yes, it is very different topics. So I wonder what will you show us today?
Yeah.
I am really excited.
Yeah, well, there's going to be a few demos, so I need to do the requisite amount of praying before we start. So I'm going to switch across. There we are. So yeah, I alluded to this earlier. I'm Pete Gallagher, a freelance software developer. I'm also an Azure MVP and a newly inducted Pluralsight author as well, so that's quite exciting. I've been programming in the IoT space for decades now, all the way back to, I mentioned in my previous talk, an internet connected Royal Mail stamp vending machine that we were able to dial into. So that was a fun project back in the later parts of the 90s. I'm also a meetup organizer, as I said. So I run .NET Knots, Knots IoT, and co-organised Knots Dev Workshop as well. And also I'm a STEM ambassador and Code Club volunteer, mainly because I've got two small girls at home who wander into my office quite often asking what I'm doing. So I'm quite well motivated to children and young adults STEM subjects. So today we're going to be talking about IoT and DevOps, and we'll start with just a simple benchmark IoT app, and then we'll look at an open source DevOps pipeline, and then we'll leap into the Microsoft space and look at IoT Edge and Azure DevOps, and then either as we go or at the end we'll look at some questions as well. So for those of you that may not have caught the last talk, what is IoT? Well, Wikipedia basically say it's a whole heap of objects talking to each other, which is a pretty good way of narrowing it down. That in our case, normally things like the Nest thermostat or the Amazon Alexa or the Philips Hue bulb or wearables, and then into logistics and even things like internet connected cows, which is a little bit of fun, but an interesting use case. It's big. Certainly back in 2018, Gartner at that point forecasted that there'd be 14.2 million internet connected devices by the end of 2019, and then that'd go up to 25 billion by 2021. Well, they were a little bit wrong. Certainly Statista had that at 2019 at 26.66 billion, and then 2021 they reckon 35.8. So that's a heck of a lot of internet connected devices out there. So it's a burgeoning market. If you're struggling to figure out what IoT actually is, the IEEE have come up with a definition. It's a ridiculous number of pages long and mostly words, but if you want to go and read something and you can't get sleep, then I recommend you go and read that. Being as we're going to combine a talk on IoT and DevOps, we better talk about DevOps. Again, Wikipedia have that as a set of practices that allow for continuous delivery, essentially, where we're going to combine the worlds of software and operations together to get DevOps. They say that you need things like deployability, modifiability, testability, and monitorability. I think they've just made up quite a lot of words and put ability at the end there. But the essence is true, and it's really about continuously delivering value all the way through the life cycle of the product. We see diagrams like this quite often, where we go through plan, create, verify, package, release, configure, monitor, and then we rinse and repeat again. But again, it's just about closing the loop and being able to deliver things fast. As a little side note and a plug, I'm also part of a podcast recording with a few other people. We talk about all things DevOps and Agile. So I do recommend you go ahead and check that out. We've got 4 episodes up currently. I think actually tomorrow we're going to be recording another one, so that one will be online in the not too distant future too. So we're going to start with the simple IoT app. I'm using Raspberry Pis here, and that's my tool of choice. The basic idea is we'll have a thing, in this case a Raspberry Pi, and then we'll connect that out to Azure, to an IoT hub. We briefly spoke about IoT hubs in the last talk, but this is a data mechanism. Think of it like a BT switchboard at the edge of Azure that all of your devices, millions of devices, can all connect to concurrently and communicate up to Azure and down from Azure back to the device. And then just to see what's being sent up and down, we'll run up a little local web app. So let's do a little demo. So I have some code. So I've got a really basic web app here that I'm going to deploy, and that's going to be looking at the messages that are going up to IoT Hub. And I've got some code deployed out onto my Raspberry Pi, and I'm not going to go into too much detail about what it's going to do, but essentially at the bottom here, we're just going to be sending a message up to IoT Hub about some fake temperature that we're going to create up at the top here. And then if that temperature goes over a certain threshold here at 30, then we'll set a property on there to say that there's a temperature alert. And just before we carry on, Mert, are you seeing everything that I'm seeing? Is it okay? All okay?
Yes, but can you please increase the font size?
There we go. Is that any better? Oh, too much. No.
Yes, that's better.
Yeah, good. So we won't spend too much time in any of the code for this. What we're not going to be doing is deep diving into anything because we've got an hour content to get through. So I've already deployed this code onto a Raspberry Pi. So I'm going to flick over to a putty session I've got open here, and I'm going to run this up. So that's going to start the code. So you can see there that it's sending messages here up to IoT Hub. So if I now flick across to the code for my web app, I can run this locally. I just hit F5 and wait for that. Now it's listening on port 3000. So if I switch over to my browser and refresh this, and all being well, if everything's working, there we are, good. So that's the first part of the live demos that works. So that's always a good thing. So we can see we're plotting a graph here of humidity, and they're just random values that I'm sending out from my Raspberry Pi up to Azure. And then this web app is connecting to the IoT Hub in Azure and monitoring for those messages and then just plotting them on a nice graph. So it's nothing particularly complicated, but it does show that messages are going from my device up to Azure and I'm able to see those messages locally. We can just quickly prove that it is live. If I stop this code, in the background, you can see now that the graph stopped moving as well. So essentially, we've just got a benchmark to work from here. There's no DevOps involved in any of that. If I switch back to my slides, we can add a little bit of collaboration into this. So this is what we had currently with a thing and an IoT hub. We can add GitHub and we can pull the code down from GitHub onto the Pi if you like. It's not ideal, but that will work. But what we can do is we can host the web app in Azure, and then we can use continuous deployment to deploy that code from GitHub directly to that Azure web app. So I've got that working already. I can just, if I flick back to my code here again. So that is all working just there. And I need to restart my code again. Close that out of the way. And then just here, if I refresh this page, we see this is one hosted in DevOps, rather in Azure, in an Azure web app. And what I can do is if I get the code open here, yeah, this is the web app. I can change this to say MS How To. So let's just stop this code. We see we've got one change now in the source control. If I check that in and push it up, and then over in Azure, this is my app service working here. If I go to the deployment center, I've hooked this up so that it's monitoring that GitHub repo. There we are, and we're running a deployment command at the moment. So it's spotted that I've checked those changes in. Now it's saying it successfully grabbed it and it's active. And then if I refresh my page here, let it spin up. Web apps take a second or so to warm up. There we are. Now we have MS How To now sitting there. So that was quite easy to plug changes and get those to deploy automatically. Obviously, we're shortcutting all of the dev and test and the stuff that you really should be doing there. But as a quick demo of proving that you can add a little bit of DevOps to something like this, then you know that works quite nicely. So in back to my slides, that's a little bit DevOpsy, but it's not much DevOps in there as I'd like. So currently we have that sort of a thing. So we have the Raspberry Pi in the middle, and that's going up to Azure. We've got a web app that's running there, and that's monitoring GitHub and automatically pulling changes into the web app. But there's nothing that's actually pulling changes directly onto the Raspberry Pi. That's a manual process, or you're having to write a script or something like that, which isn't ideal. So what can we do about that particular link there between GitHub and the Pi? Well, we could employ something called Jenkins. I'm sure people have heard of Jenkins, but if not, we'll go into a bit of detail about that in a minute. And then we can use something called Docker Hub, and then we can run Docker on our Raspberry Pi. Now it's a little bit less simple, of course. We've got quite a lot of moving parts that we've introduced now compared to our simple IoT app that we started with. So Jenkins, it's an open source automation server. So if you've used something like Azure DevOps that we'll talk about later, this is an open source equivalent of that. And Docker Hub. So Docker is a virtualization platform, and you can run little mini OSs, if you will, operating systems in containers, and you can encapsulate all of your OS operating systems and then the customizations to that within containers, and they're all isolated, but you can have them talk to each other. And then Docker Hub is a way of being able to host those containers somewhere in a registry to be able to then pull them down. You can grab the latest one or specific versions that way. So let's look at a demo of that. So over here I have Jenkins, and this is what the build pipeline of Jenkins looks like. And again, I'm not going to go into a massive amount of detail here, but what I will do is that if I flick back to my Pi just here and stop this code and clear that off the screen, if I do a docker ps-a, I've got two Docker containers here. It's wrapping it across the top, but this first one here, that's my Docker image for the code that I'm about to show you. Essentially, it's the exact same code that I just ran directly on the Pi, but it's going to run in a Docker container. The next container down is called Watchtower, and that is going to monitor the Docker registry that I pointed at for any changes to the container images that I published there. And if it spots a change, it's going to delete the existing container that's running on the Pi and then automatically bring down the latest one and start it running. It's okay for production. It's not ideal, but this is just one way of doing it. But you can see that these have exited, so I actually need to start those containers up. Start the first one. I'll start the second one. I can't have those running at the same time as the IoT demo code I was running earlier. Whoops. Because they're going to conflict, because they're both going to try and use the same set of GPIO. So it's not ideal. So just as a little aside, this is what I've got hooked up in front of me. So I've got two separate systems, and this one I'm pointing at here is a Raspberry Pi 3B Plus, and that is going to be my open source IoT kit. So this is the one that I've got hooked up to Jenkins that I was showing you there. In a bit, we'll talk about the Microsoft equivalent, which is this side here, and we'll go into that one in a bit more detail when we get to that point. So they're started now. And so if I do a Docker ps-a on that, then we can see that they were created about an hour ago, and it was up for 58 seconds and 45 seconds. Now, if I switch back to my web app, there's that same information going up to the Azure IoT Hub. So that's pretty good that that's working there. I'm going to close that actually, and we can look at those same messages directly in VS Code as well. So this is the code that's running on that in that Docker image. So it's not particularly complicated. I'm not going to go into it in any detail again. I already did explain. It's just sending some random temperature up there. And it's doing a bit of console logging as well. Now in a Docker container, those console logs actually come out as logs on the device. So I can do Docker logs and grab the logs out of that. And there'll be quite a few of them. So it'll scroll through and you see sending message to IoT Hub with an exclamation mark on it. And I can actually change that. So from Jenkins on the end of that. If I save it, you'll see that there's a change I can make. So change message. And I can check that in and push it up. And if I flick back to my Jenkins pipeline, if you give that a second, and you should see, there we are, that we have a pending. And now it's starting the process of building it. So this Jenkins instance is running in a VM in Azure. And if I get the console output up, we'll start seeing what it's doing. So it's noticed that I've pushed up some code to GitHub, and it's grabbed that latest version of the code. And then we're doing some Docker stuff here. And one of the things we're going to do is spin up something called QEMU. Now, the virtual machine that I'm running Jenkins on is an x86 machine. Actually, it's probably x64. But what you can't do is take a Docker container that you've created on an x64 or x86 machine and run it on a Raspberry Pi, because that's an ARM32 architecture. So you can spin up an image, a QEMU image, and it's an emulator, and it's going to emulate the ARM32 architecture. And we build a Docker image in a Docker image there, emulating ARM32. So we get an ARM32 compatible Docker image out of it. Next up, it's going to create the Docker image within that QEMU instance. And that's what all of this is doing. And again, I'm not going to go into a great deal of detail, but we're going to pull in some packages. And we're then just updating some bits and packages in here. And here we're doing a build. There we are. Let's grab some bits from the Debian operating system. And it's going to unpack those. And this process just takes a few minutes, and I don't mind showing you this because I've passed enough time describing what it's doing, waiting just a little bit longer for it to finish. But we don't need to look just there. Go back again. You can see that I've had a few builds before, so 4 minutes 31, 4 minutes 44, and because it knows the average amount of time, it's able to predict how long's left in that particular process. So what we're hoping that's going to happen is that I've been able to push my code up to GitHub, which is here, look. So if I do a refresh on that, come on, there we are. And there's my changed message. And this was checked in 3 minutes ago. And over here in Jenkins, I have this pipeline. I can scroll down. There's a heap of settings here. This first one here is the GitHub project that it's checking in on to see if there's been any updates, and then the actual pipeline. So we do some bits and bobs of setup, and then we clone a repository. So that's that same repository that I was showing you there a minute ago. And then we do these build and push images. The good thing about this is that it's using username and password variables that I've passed in. And when I flick back to the build in a minute, you'll see that they're obfuscated, which is good. So you can store these in your Jenkins instance and they don't get exposed in the logs, which is nice. We tell it to be experimental there because we need that setting. And then we're logging into Docker because later on we're going to be pushing that Docker image up. So this is the information about the virtual machine sitting in Azure. You don't need to see that, but you can see that we get quite rich information about what it's actually doing. And then over in Docker Hub, we get the list of the different images. So that's saying a few seconds ago because that's when I actually updated it. But if I refresh that page, so 56, 64 days ago, 2 months ago. It's nice that it's not in order, isn't it? But 20 hours ago for 63 and 65 was a few seconds ago. So that looks like perhaps my build pipeline is completed. So if I go back to that, and it has indeed. So now over on my Pi, I can do a Docker PSA. We just wait a second. And all being well, we should say that you should see that Docker image disappear and a whole new one appear. As always, with any live demo, there's always a little bit of waiting around. It doesn't take too long, normally. Unless you're trying to demonstrate it to people, and then it takes ages. Let's leave that just for a second. It will do it. Won't be long. But we can see that we have our latest image here. One of the problems is that it's 129 meg, so it takes a little time to download it before it can do anything with it. So we can see that what's happened there is that we've checked in some code to GitHub. Jenkins has spotted that that code has changed. And that's kicked off this build pipeline. At the end of the build pipeline, the created Docker container was published up onto Docker Hub. And then my Pi is sitting there nicely, checking to see if there's a newer version. And it's only going to do it sort of once every few minutes. So that's going to take a little while to do that. So I'm not going to make you sit there and watch it. But I'll check back in on that in a minute and we'll see if it has spotted it. So we can switch across to the slides. So that was the open source version, but obviously I'm an Azure MVP, so I need to talk to you about the Microsoft equivalent of this. There's a few things that we can look at. So this is what we've got currently. We've got the Pi sitting there in the middle with Docker running on it. And we've got a web app and IoT Hub sitting in Azure. And we've got Jenkins, actually, that's over there in Azure as well. And then we've got Docker Hub. And we just push code into GitHub and then everything gets orchestrated. So we can get rid of Jenkins out of this equation and we can get rid of Docker Hub. And we can use something called a container registry. which is exactly the same as Docker Hub, only it's going to live in Azure. And we can run the IoT Edge runtime, which actually runs on top of Docker. So IoT Edge, this is a mechanism of running small containers, and it's orchestrated by the IoT Edge runtime. It's really so that you can shift your processing out of the cloud and down onto the device, which is sitting at the edge. It's called at the edge because it's usually the intermediary between the sensor data or the sensors themselves and the rest of Azure. Just to give it a little bit of scope, by 2023, there'll be 20 times as many smart devices at the edge as regular IT devices. So really, the people are starting to make good use of devices like the Raspberry Pi, but in that same form factor way that you've got some relatively powerful processing able to happen down at the device level, and then you just send the results of that back up to Azure. So we have a thing, and it runs the Edge runtime. So I'm going to call it an Edge device. So the Azure runtime runs on there, and that's going to orchestrate each of these different modules. They're called Docker containers, and each Docker container has a specific function. So you have one for telemetry and one for machine learning or AI, and an Azure function that can do some form of processing as well. And the reason being is that you can then start connecting things directly to the device and make business decisions directly on the device. So you get fast turnaround. So if you imagine something like a self-driving car, for instance, then you don't really want to have to wait for that round trip up into Azure and back before you can make a decision as to what to do. You need that fast processing time to happen directly on the device. So another demo of that, but I'm hoping that, oh look, it's been up for 2 minutes. I've been waffling for 2 minutes and it's actually gone up. So let me do a Docker logs on that now. There we are. So before it just said message from IoT Hub, and now it's saying from Jenkins. So as I say, that went from GitHub to Jenkins, from Jenkins to Docker Hub, and then using Watchtower, I was able to pull down that version of that container back onto the device. So that is pretty DevOpsy now. And again, this is a demonstration. Really, you'd be having dev and test and prod as separate release pipelines in there, and you'd be gating them. And I realise my DevOps is lacking there, but you know, the process is there nonetheless. So looking at IoT Edge, I am going to, before I do that, I'm just going to quickly, I've got these two Docker images. I'm just going to stop them just so that things are nice and clear. It's dead easy to stop Docker images. Just Docker stop. That one will take a little bit longer than the next because it's busy. There we are. And that's those two stopped now. So that can go away. So let's look at the code that we've got here. So I've got some code just here. So I'm going to clear this off the screen. Otherwise it's a spoiler. As I mentioned before, IoT Edge works on the premises of containers just like Docker does, only they call them modules. And you publish these modules up to a container registry, and then you tell IoT Edge, which lives in an Azure IoT Hub, which I'll show you in a minute, which of these particular modules you want on each device. And it can get quite complicated, but we're going to be concentrating on one single device. Now, this should be running, so I can grab the details from my IoT Hub just here. So I've already got them, and I've got an IoT Edge device, and I can drill into that IoT Edge device like I did just a second ago. And we have modules in there as well. Expand that, and we have an Edge agent, an Edge hub, and a simulated temperature sensor, which is quite similar to the basic IoT demo that I gave you before, in that it just ramps up a temperature, a random temperature. Actually, it's just an incrementing value, just so that we can send something. And the node module here is taking that and sending that up to the IoT hub. So let me have a look and see if we can start monitoring that built-in endpoint. So this is going to be looking at the messages on the IoT hub. But what we might find is that nothing comes back because it's been running a while, and if the simulated temperature sensor is left to run for too long, then it just gives up and it can't be bothered. So actually, this says that there's already one monitoring somewhere. Any of these? No. Let's try that again. So usually it would pop up 2 or 3 different things. There we are. So that's created some partitions, some consumer groups. So we can see nothing actually happening there. So I'm going to flick back to my other device. So this is now a putty session into my other Raspberry Pi. So back here again. So we have here a Raspberry Pi 4 in this black box. And I tend to do that just because it gives me a little bit more oomph when I'm doing containers. But as you saw from the Jenkins version, it runs perfectly well on a 3B plus, and we're not doing anything complicated. But should you do things like any ML or AI stuff, then a bit of extra power is not going to hurt. We've got a really basic circuit on here as well that I've hooked up, and if I press the button, I press it and toggle that LED on and off. So really complicated circuit, really complicated program, but yeah, it's good for demoing. So if I do I can do the same Docker PSA here, and we have some modules running here, including a simulated temperature sensor. So I'm going to restart that simulated temperature sensor, and then go back over to my code. And what's going to happen is it's going to wait for a little while, because that simulated temperature sensor will start at a lower number of degrees than this threshold that we've got here. Well, actually, we're receiving that threshold, but we're checking in this code to see whether or not a particular message has gone above a particular temperature threshold here before we actually do anything. And there we are. So we've got some alerts coming out now of that. So what I can see that this is actually set up for the next demo, but this code I can deploy directly from Visual Studio Code and tell it to go up to Azure. And then, in fact, what I'll do, I'll switch over and I'll show you what's actually happening. So we've got a IoT hub, which I've created in Azure, and I'm not going to go into detail about how to create them. I did that in the previous video. So this is an IoT hub that I've got in Azure, and down here on the left-hand side, down here on the left-hand side, we have Edge devices, and if I can click into IoT Edge, zoom it running. Then in here I've got the list of IoT Edge devices, and I've only got one, my IoT Edge device, as I've called it. And on there we have a set of modules. So when I did that Docker PSA earlier, we had a node module, an Edge hub, a simulated temperature sensor, and an Edge agent, and that's mirrored here. So this is where you're telling IoT hub to tell the Edge device which of these modules it needs to be using, and they get orchestrated with the Edge runtime on the device, and that pulls down what it's been told to pull down here. So if I go back now to my Edge solution, so at the moment that's saying DevOps alert every time that goes up. So that's, yeah, 37, that's gone up. But I can deploy to this device, create a deployment for a single device, and tell it the deployment manifest that I'm going to use. So the deployment succeeded. Now this process takes a little bit of time, but essentially what that's done is told the Edge hub here what it wants you to deploy onto the device. I can go into the node module, and I've told it that I want it to use 0.0 0.56 and this ARM32 one. What it's currently got is my DevOps demo sitting on there. So this process, there we are. So it says that it's done it, and there. So that's alert 1. So that's me able to build some code here. I'd already built it and deployed it to the container registry, which you do again through VS Code. You can build and push that IoT Edge solution. So I'd already told it to do that. So that was already sitting in the container registry. And when I told it to create a deployment for a single device and I pointed it at my IoT Edge device, that instructed the IoT hub here to update this desired package. And in fact, if I go across to my container registry, I can see that I've got 3 packages in there at the moment, and this is the one that I deployed earlier, 0.0.56. So it knows that that is there because that's the desired value that it's grabbing. So it knows to grab that because I've already hooked it up to my container registry. So it grabs that information, and then at that point, the Edge device, if I do a Docker PSA again, we'll see that that's been up for a minute now, that particular module, which is good. So it knows to grab that. So that's what the Edge runtime is doing down on the device. This Edge hub is taking messages and sending them up to Azure, and this Edge agent is orchestrating those container changes. So that works quite nicely, but that's not very DevOpsy still. So how do we fix that? Well, we use something called Azure DevOps. So if I, in fact, go back to my slides, Azure DevOps. So Microsoft say that it provides developer services to support teams plan, work and collaborate. And again, this is just a way of closing that loop. So between your code and the check-ins, we're able to build that information out and to send it down to devices. So which is what I'm making use of in Azure, but you can actually host in GitHub just as well. And then we have pipelines, and those pipelines are doing our build and our release. And then we have boards, so Kanban boards, and we've got test plans as well. I'm not going to go into any detail with these. And then artifacts, and you can actually run it on-prem on a server as well. So we have the Azure repo instead of GitHub, and our Edge device sitting there with the Azure runtime on it. We have VS Code, and that's going to publish code up to the Azure repo. So what we can do is, we can do that now. I switch back to some code here. So I've got DevOps alert, and I'm going to just put MS how to there and save that. And then change alert. So that's the alert that's going to come out of that. Oh, I can spell alert. Let's have it right, yeah. Check that code in, and then I'm going to come back to that. So once that's finished, check it in. Go on, get up there. You can do it. There we go, that's gone. So it's got into the repo. That's going to trigger a build and release pipeline in Azure DevOps, which I'll show you shortly. What will happen at the end of that is that when it's released, part of that release cycle is to push it out to the container registry and then instruct the Azure IoT hub and the Edge device in particular, in this case, to go ahead and grab that latest version of that that image. And then, so it's gone into the registry and onto the IoT hub, and then that lot will go back onto the IoT Edge device that way. What I've highlighted in the top left-hand corner is that, again, all of the services that you're going to be running in Azure are going to be building with x86 or x64. There is actually an ARM64 a way of building, but again, we're running an ARM32 architecture here, so that's no good. So what I've got that's not in front of you in those two Raspberry Pis that I showed you earlier is I've got a third Raspberry Pi sitting here that's running what's called a build agent. And what happens is that gets integrated into that build and release pipeline. And when it gets to the build part, it sends the code changes down to my another Raspberry Pi that I've got here running a build agent, and that Raspberry Pi actually builds the container image and ships that back to Azure DevOps. So you can build directly on the architecture that you're going to be deploying to, which is fantastic. It would be nice, I think, maybe if you could do that directly in Azure, but I quite like being able to build directly on the architecture I'm deploying to. It's going to give you a bit more stability. So the demo is me going across to Azure DevOps, and if I go to repos on the left, pipelines on the left, and then pipelines. So this is my build pipeline. We see that there's actually one in progress at the moment. So if I go into that and see what it's doing, and go into this change alert run. So we have an agent job running. And so right at the top here, it was checking out the code from GitHub. And so I've got this GitHub repo sitting here, which is within my DevOps project. What we do is replace some tokens. I can show you that actually. So in my module.json, we have a version, a build definition name and a build ID. And I'm doing that replacement up in Azure so that I can increment the build ID every time I deploy. You need to be able to change something so that the Edge runtime knows that you've got a new version there. So that's what that's going to do there. And then it does a build just here. So it builds the module images. So to do that, it's going to send it down, and you can't really tell unless you look in a little bit more detail, but you can see home Pi my agent, and that's actually running on my build agent. And so we've got work 1s edge solution modules, node module. In actual fact, I can show you that. IoT Edge build. I'm dialing into my, let me just bump up the size of the font so that you can see a bit better. 16 will do. There we go. And so it said cd home Pi. I don't theoretically need that because I'm already there. My agent. So we can see we've got some bits and bobs in there, but I can go into CD work, and then I can go and have a look at that, and then CD1, CDS, the Edge solution, CD modules. I could have just copied and pasted. It's far more interesting watching me type this, isn't it? Surely. Node module, and if I look in there, we see that's that Docker file ARM32 v7. So as I say, this is another Raspberry Pi. It's a 3B plus again, sitting on the other side of my office over there, and it's been instructed through that build agent that I've got running on here to build that Docker container, which is what it is, as a module, and then ship it back up to that pipeline. So that's what that's doing just there. So it's grabbing it. This is running the bits that it needs onto the Docker container. And again, I'm not going to go into too much detail with that. And then it pushes that Docker image up to the container registry. So it's only updating it. So it only needs to update part of it. So that's why it's saying the layer already exists. So if you're only making a small change, it only needs to make a small change to the container as well, which is a good way of keeping things fast. And then it copies to a drop folder, and then a drop, and then it just does a checkout here. So what that should have done is at the end of that build pipeline, it should have triggered a release. And that's what we can see here. So if we go into releases, go to release 42, then we have a release in progress, and I can look at the logs of what it's doing there. So it's initialized the job, grabbed that drop. So that's that container image that's in the registry there. And it's generated a deployment manifest, and then it's deploying it to IoT Edge devices, and really don't need the S on the S of devices there because it's only one device that I'm sending it to. I'm just going to send it to my IoT Edge device, and specifically to my single Raspberry Pi there. So that says that's finished deploying. And then after that, it's going to do this continuous monitoring. If I go back to my node module here, then here we've got version 57, which is what we've just built. And that was created at 5:40. So 5 minutes ago, actually, was when that was created. All of these things just take a little bit of time. It's installing some bits on there. Now, there seems to be quite a delay between when you finish deploying in this Azure pipeline here and when it reaches the device. If I go back to here and we just clear that output, let's just see what it's saying at the moment, but I'm betting you it's not updated yet. So that's saying DevOps alert, which is actually the previous image we're looking for. DevOps alert MS how to know that we've got the very latest version. So that's not coming, that's not on yet. See, the temperature's all the way up to 100. So what I'll do, I'll just reset that temperature for now on my Edge device. Let's do a Docker PSA just to make sure we're up to date. So 6 minutes ago, it grabbed that original DevOps image, the version 56. We'll get 57 shortly. Here's my temperature sensor. Let's restart that image, that container rather. Docker PSA, and then that's been up. And then down here, we'll see the temperature should drop back down eventually. Clear that out so we know what's happening. So while we're waiting for that, because that's going to be a little while, just check just in case. That's still been up to 7 minutes. So I will flick back and we can have a quick look at what's involved in these pipelines. So this is, again, this is the build and release pipeline, build pipeline rather, that I've got in here. And I can, if I click on edit, we can have a look at what it's doing. So we have a few tasks. We've got a replace tokens in here, and that's going to replace those 2 tokens. We're going to build those module images and then push the module images to the container registry and then copy that to a drop folder just here and then publish it. So that's what we're going to do in that particular pipeline. And then in releases, we can edit that. And most of the interesting stuff happens here in tasks. So we generate a deployment manifest, which is very similar to what we have over here with this deployment. So it just tells it what, if I just get rid of, if I don't get rid of it, let's pull it down a little bit, down there. So this deployment manifest is telling IoT Edge, in fact, this is the one we really want to look at. Deployment manifest, that one. There. So we've got some extra variables in here, so it's going to grab a password and an address out of my environment variables, and they're stored as variables in my DevOps pipeline, and we're going to replace those a little bit like what we did in Jenkins, so that we don't have to expose our username and password to the whole of the world. And then we have a Docker. It's telling it that it's going to run the IoT Edge agent and an Edge hub. And then here we have another build number. So similar again to what we did in Jenkins, and a build definition name. And those will get replaced in the DevOps pipeline as well. And then we have our simulated temperature sensor, and then some information about routes on the hub. So you can have messages and they go between each of these containers. And so it's going from the sensor temperature sensor and into the node module. That's what this is telling us. And then we've got something called a twin here and some desired states, and we're setting a temperature threshold of 25. So over here, has anything happened yet? Still saying DevOps alert. So again, this takes a bit of time to, in fact, let's turn that off so we know where we're at. That can take a little bit of time, and I'm not going to make you sit and wait, because that can take, sometimes I've seen that take up to 20 minutes before, which is just frustrating. But we can see that the release pipeline itself is actually finished. What I find is when we go into the IoT Edge device, which is where I am here, and this is information about the node module. So if I refresh this, there. So actually, I think we might find that that has just done it. So if I do a Docker PSA, oh, that's been up for 18 seconds. Oh, that timing was perfect. And there we are. So we have DevOps Alert MS How To. So that's gone from GitHub, essentially an Azure repo in our Azure DevOps project. So I've checked in that code. We've built the container images on a Raspberry Pi as part of that pipeline down here in my office and shipped that back to that pipeline. It's done the wherewithal that it has to put that into a container registry and then tell the IoT hub, and specifically that IoT Edge device, that it needs to be using a specific version of a module. And the IoT Edge runtime on the Raspberry Pi 4 there has grabbed that module and started it running. And we can see the result is that we've got a slightly different alert. Yeah, woohoo! But you know, again, we've closed that loop there and proved that that's working. So yeah, so if I switch back to my slides now, and by the way, that was 4 or 5 different live demos you saw there, and they all worked. So I feel reasonably happy with that situation. So the links here for the bits and bobs that I've spoken about. So IoT hubs and Jenkins and Docker Hub, and there's a nice Jenkins and Docker demo that I based some of this off of there in that YouTube link. So go ahead and watch that. That's they've got quite a nice colourful LED demo that they've done on that. And then the IoT Edge runtime and a deep dive there on YouTube about that, and a bit about DevOps. And then for the I/O stuff on the Raspberry Pi, I've used this node package called on/off, which works quite well. So I suggest you go and have a look at that. If you need to contact me, then the best place is on Twitter. So I'm @Pete_codes is the best place to come and find me. Send me a message, or you can email me there at pete@pjgcreations. I'm writing a blog post series on this specific topic. I'm up to part 7 so far. So if you go on the Pete Codes website and then hit the blog section there, you'll be able to see the various different blog posts. It's not finished, but it's designed there to get people up and running with this whole pipeline that we've got running as far as the IoT Edge solution is concerned. I need to do one for the Jenkins side as well, but time. As I mentioned earlier, I run Knots IoT. I co-organise .NET Knots and Knots Dev Workshop. I'm on the board of another group in Loughborough called LATI, which is a high-tech engineering group in Loughborough. And I also help create the Agile Engineering podcast. Today's slides, they're not there at the moment, but I'll publish them a little bit later on. So that'll be the bit.ly that I'll use for that. So do take a screenshot if you like. And other than that, please do get in touch. At that point, I'm going to stop sharing my screen. And we can go through any questions in the chat if you like. What's the extension you've got installed on VS Code for IoT Hub? Yes. Let me tell you what I'll do then. I'll share again. So there's an Azure IoT Toolkit. So if I go to extensions here, so this Azure IoT Device Workbench is the one you want. And that actually contains all of these different bits and bobs. Actually, I think it's this one now, Azure IoT Tools. Yeah, so this is the one. I'm lying to you. Because this has been developed over a good number of years, actually. Used to be each of these extensions was a separate thing, but when you click on it, this extension is now a part of the Azure IoT Tools extension pack, and the same with the Azure IoT Edge extension. So yeah, you just need this IoT Tools, and in fact, if I paste that link in the chat, then you can, there we are, you can grab that. So is there any other questions that will make sense to you, Mert?
Yes, that's awesome.
I feel quite happy that all of the demos worked, and I was able to waffle on long enough that the build and release pipelines in Jenkins and IoT and DevOps, Azure DevOps, all sort of synchronise themselves, which was quite nice, actually. Quite impressed with that. Normally I'm sitting there twiddling my thumbs while people are staring at me. Do you have any questions?
No, I don't think so. So thank you very much, Pete. That's I cannot speak right now. That's very different. That's a very different session for me, because this is the first time I am seeing the Raspberry Pi with Azure DevOps for Jenkins. So do you know any real life scenarios that we can use Raspberry Pi with DevOps? Because there's a demo, but is there any other stuff?
Yeah, well, I mean, IoT Edge is the thing that I'd talk about, certainly, because you can do things like cognitive services there. So, and you can run Azure functions. You can even run an Azure SQL, rather a SQL Server database in a container on the Pi, and do sort of all your local storage sitting there. And then you can connect that up then through IoT Hub and start sending information telemetry out to Azure services. But you can do your processing on the Pi there, and as you've seen, it's hoops you've got to get it to work with Azure DevOps, but it's not impossible. And I use it for a project for a client, as it happens, part of a building monitoring system. And some people will frown at people using Raspberry Pis in production, but so long as you do the right things, then it's a really good way of doing sort of low volume prototype level, all the way up to sort of low volume prod stuff. Even as long as you manage it correctly, it's okay. Really, you probably should be building your own hardware at some point. The biggest risk being the SD card on a Raspberry Pi, but there's ways around that now. You can even run the operating system off of a USB thumb drive rather than an SD card, so a little bit safer. Usually it's power down that causes the problem. So if you use a proper power board and a bit of script in there for an on-off button, those two things tend to mitigate quite a lot of the risk. And certainly a Raspberry Pi 4, that's massively powerful now. A lot of people are using this for signage because it's got dual 4K 60 hertz outputs on there. So yeah, and 4 gig of RAM should you want it, and all for about 50 or 60 quid. So for that price point, you can't, there's no way you'd be able to build something for that sort of price without the volume. So I like it for that reason, and it runs a full version of Linux, so it can do anything that you'd like, rather than you're trying to hack things together. I've seen development boards from people like D-Link and stuff that are fab at doing one particular thing really well, but they're just not flexible, and they tend to be very limited in scope and processing power and memory and things like that. So yeah, it's the Raspberry Pi. I love the Raspberry Pi.
Many thanks, and I want to say this in front of the audience. This is a very new stuff and interesting stuff for me, and I want to continue to these sessions with you about IoT. How does it sound?
Yeah. More than happy to do that.
Okay. Thank you very much.
All right. Thank you.
Okay.
I'll see you again soon.
See you. Bye.
Cheers. Bye.